With scanning, it becomes more possible than ever to achieve design certainty. With design certainty, there are new opportunities for saving time and project cost. PMC is well versed in the evolution of the technology, helping clients avoid mistakes and pitfalls made with earlier versions. As we will show, laser scanning can provide value throughout the project lifecycle, from concept and design through facility management. PMC has been a leader and innovator in laser scanning technology for over 15 years. Our Director of Scanning and CAD Technology, Chris Mounts, has won several AIA TAP awards for his work in AEC digital engineering. Today, terrestrial scanning is used in all phases of the projects, whether it's fast and accurate feasibility studies or ongoing facility maintenance and operations. The challenge is identifying at what stage of the process scanning can yield the highest return for you. PMC can help. The planning stage of the project is the most critical. A detailed analysis must be done of the facility and the data that will be required. The scanner is a line-of-sight device which requires planning of each individual scan location. Other factors include whether a facility is occupied and how much detail is needed for the final model. For example, will equipment or MEP be removed in renovation? This video shows a point cloud, which is the complete record of the building, including geometry. The process of producing this data is to combine the individual scans during registration and create the point cloud. 2D drawings and elevations, or a 3D model, can be drawn from the laser scan point cloud. This is a sample of the Revit model created for this project. There is still a need for 2D drawings, construction and installation documents, for example. This can be done from the same laser scan data. Today's technology provides access to scan and model data in a wide variety of formats, including web sharing and even tablets and smartphones in the field. This will greatly add to project collaboration with visualization. While there are many advantages to just having an accurate as-built of the facility, there are many other uses that will reduce or even eliminate field change orders. It is possible to overlay the scan data directly on the CAD layout to visualize the variances and where corrections are needed to be made. Either through inaccurate field measurement or design changes, errors in the design documents are frequently found in construction phase. Laser scanning for accurate as-built conditions can save countless hours of corrections to be made on the construction site and cost overruns. The scan data can be displayed in many formats. This color chart gives a graphical display of dramatic floor level deviation. The red indicates +5 inches and the blue indicates -5 inches. The original remediation plan was to pour concrete to level the floor, but the 10-inch variance called for alternative plans. PMC's expertise in architecture allows us to work with the scan data in many formats, giving the optimal views required for a specific project. This allows for the project team to see existing conditions that are traditionally difficult to identify. Architecture is dependent on photos of existing elements, but also requires relationships between elements. Photos can show existing conditions, but cannot determine exact relationships between elements. During the scanning process, the digital scan is taken, and in the same position, an associated photo is taken to provide the ability to contrast and compare. For this project, we were called in by the general contractor, Barton Mallow, as no as-built drawings were available. There was a need to capture exterior data and interior conditions. The building was 11 stories tall, and we were able to capture the exterior data from ground level and maintain half-inch accuracy to the top of the building. The structural engineer needed as-built conditions to determine the viability of the existing elevator shaft. Black and white scanning can capture data in complete darkness. Our scans were also able to show conduits in the shaft that were previously unknown. As this building had been abandoned for over 40 years, putting someone on the roof to take manual measurements and condition reports was not an option due to safety concerns. Our field team was able to safely and accurately gather the data from the rooftop of an adjacent building. This particular project is a record of the condition of buildings that will remain while the rest of the city block is new development. If there are questions of damage to the existing buildings that was caused by the demolition or subsequent construction of below-ground new buildings, this record can accurately measure before and after conditions within 1/8 of an inch. A post-construction scan can be overlaid on the pre-construction one to document condition changes. Architects can quickly create demo plans by drawing directly on top of the point cloud, making exact demo plans with exact measurements. Many times, confusion can be caused by insufficient demo drawings. For example, if there are multiple conduits in an area, but the demo drawing only references one. During schematic design, for true as-built conditions can be created in far less time than designed from manual measurements. To visualize proposed changes, new elements can be added to the model to evaluate multiple scenarios. Any design changes can be checked for possible clashes with either existing monuments or planned changes. A newer AEC project model is the integrated project delivery. All parties in the design and construction of the project assume shared responsibility in the completion of the project. Laser scanning can be done at regular intervals during construction to assure accuracy to the model. This picture shows the model overlaid against the actual installation, detecting any errors before additional work has been done. This case study is a new well water line for an automotive plant. The plant layout was in 2D, and the architect designed the new line also in 2D. The automaker wasn't convinced of the accuracy against potential clashes due to the density of the MEP in the planned route. PMC's solution was to 3D scan the route of the proposed new line through the plant and then convert the architect's drawing from 2D to 3D Inventor and overlay the model into the scan. A series of collisions were detected, including existing piping, fencing, and numerous light fixtures. This study, which was completed in under 2 weeks, saved an estimated $60,000 in field change orders, and more importantly, valuable time lost in new fabrication. Scanning can also be used to facilitate the bid process with subcontractors. For remote job sites, the review meeting can be held online, eliminating the need for everyone to travel. Additionally, the data files can be posted online for additional reviews. Everyone will be working with the same data, and multiple trips to the job site can be eliminated. Laser scan data can also be used not only to detect variance in floor levels, the data can be used for ASTM reporting and compliance with the Americans with Disabilities Act. When laser scanning first became available, the technology was slow and cumbersome. As advances have been made in scanning equipment and software tools, it is now cost justifiable on most projects, especially renovation and adaptive reuse. This is a sample of time and cost savings on a small project. Another factor that is not in this chart is the amount of delay associated with manual field checking. The total number of project days using traditional methods was 18, but the overall time span could have been months, depending upon the project location and the amount of travel. Many of our architectural clients are tasked with convincing the project owner that laser scanning is the right thing to do. Adding up the cost of multiple measurements being taken by many entities, field change orders, and project delays will more than account for the cost of the laser scanning. In keeping on the leading edge of technology, we have been successfully working with new methods of data gathering. Our first pilot project with drone data capture was the Fisher Building in downtown Detroit. The structural engineer had a need to evaluate conditions of the exterior and reduce the number of platform drops needed for visual inspection. Where the drone video captures high-resolution photography, there is also a need for geometry to verify shifting or missing stones and elements. The laser scans taken from the ground level can capture this geometry. They can also be used in tracking changing conditions of a building. Many municipalities require buildings over 30 stories to submit a condition assessment to be completed by a licensed professional engineer every 5 years. If the building is scanned every 5 years, a variance report can be easily generated giving accurate measurements of the building's changes. When Bedrock Real Estate Services in downtown Detroit bought the Book Tower and Stott buildings, the structural engineer was contracted to perform the exterior analysis of the buildings. The Book Tower was 44 stories tall and no working elevator, complicating the process. An alternative was to try publicly available data such as Google Earth. PMC's solution was to utilize the drone technology for a high-resolution video of the full exterior to give unique and accurate views for their assessment. The professional engineer had estimated 18 to 20 platform drops to gather all data. With a high-resolution video, the number of drops could be reduced to 5 to 6. At $10,000 per drop, there was a substantial savings to the project. Digital facility management involves the use of integrated systems to automate facilities management functions, beginning with a 3D model of the facility. It will also serve as a single source of all data in a visualization format for multidisciplinary collaboration. As a technology partner, PMC can also provide training, support, and modeling services to our AEC clients. Many AEC firms are still in the process of migrating from 2D into the 3D world. The full benefit of a digital facility management tool requires the data of the elements within the model, such as installation date, part number, and last maintenance date. It is critical in 3D modeling to use the power of libraries and standards. These will not only make the architectural model more accurate, but it can also aid in asset management by identifying model elements with specific detail. In the case of a renovation or adaptive reuse, the first step is to create a model of accurate existing conditions. Once the 3D model is complete, peripheral data needs to be incorporated. For example, accurately placing the model into the civil site plans. If this is completed before construction in a digital model, incorrect or missing parts of the model can be easily identified. Historically, facility management required numerous systems to collect and manage data. Floor plans, photos, plan elevations, building maintenance schedules, and building automation systems were routinely in separate sources and often in separate departments. With the introduction of Building Integration Modeling, or BIM, owners and facility managers can optimize the way that buildings are designed, built, managed, and retrofitted. Flexible technology tools can bring together BIM models, data, and operational systems integrating with facility data management systems. This environment provides a single source of truth with support for open standards such as COBE. For organizations that will maintain legacy facilities in existing 2D plans, laser scanning can be used to collect a 3D representation of the facility, thus providing the ability to track assets in all locations. There are the added advantages having the 3D data, such as using the point cloud for safety briefings for contractors and repairmen. The traditional X's and O's on a whiteboard can be replaced by a digital walkthrough. Product documentation such as submittals, data sheets, warranty, and specifications are attached to assets, systems, locations, and facilities. The BIM model will associate location and provide visualization. Visualization of assets in 3D can also be used to track mechanical, electrical, plumbing systems, and identify areas of concern, such as plumbing leaks. Building automation systems, such as energy optimization, security, and fire protection, can be integrated with the BIM model, providing the system's data in a 3D visualization format. Laser scanning is one of the many technology tools that adds value to an AEC project, from concept, design, construction, to facility management. With PMC as your technology partner, you can be assured access to the best-of-breed technologies for the AEC sector.